Hello! Today I will show you how can you modify a module, electronic module from a scooter, electronic scooter, to power a big IGBT brick, and after this to power this big 1 kilowatt engine of 24 volts. The big power, we are going to take it from these two batteries. Together they make 24 volts, and an auxiliary power, the same of 24 volts. We're going to take it from this bench power supply. The reason that I'm using two different power supplies is because I can. The idea is that you can connect both of them on a single power supply, but I prefer now as a test to do it like this. It's not going to be any kind of problem to hook it up on the same power supply. First, the modification that I made to the electronic module from the electronic scooter. As you can see here, this is the housing of the module. Inside it was this little electronic board, and next to the relay that is on the board you can see two pairs of 3 holes in which I took it out these two electronic components. The first is the power MOSFET, and this is a protection diode, a Schottky diode. This is the simplified schematics of the electronic module from the electronic scooter. Here is the main board. This is the integrated circuit that is making all the logical part of the board. Is a simple gate IC, and from that IC we get this pin out with connected with the N-channel power MOSFET, which is this one. By the way, sorry about the noise made by my camera when it's focusing. Okay, let's go back. So we have the N-channel power MOSFET that is taking the signal from the main board. Here on the main board the signal is not coming out directly from the IC. It's going through this 2 transistor amplifier, and then is going to the N-channel MOSFET. After the N-channel MOSFET we have the Schottky, this one, diode, which is only for protection. You still have the N-channel internal diode, sorry, but this is more high power to protect the entire N-channel MOSFET. And after that you have the one of the connector for the engine, electric engine. The other one is going through this relay, which is this one, the big one. The relay is connecting the engine directly to the main plus terminal. So this is the simplified schematics. What I did is removing these two components, this N-channel MOSFET and this diode, and taking one wire from this point, which is the gate, and one wire from here, which is the source, and feeding this only two wires to the brick. So we have here the brick, which we have the E connecting point, which is this one. We have okay, so you have that small E on the left side and the big E on the left side. The big E is connected to the minus of the big batteries under the table, and the small E is connected to the ground, which is this one. Okay, so you have this one, which is connected to the E, and this one, which is connected to G, gate, which is this small one under under G. Under E you find the G, the gate connector, and that is going directly to the this one. Okay, this is the only connection with the main board. So this is the signal, the pulse wide modulation, which is coming directly to the board. On the back of the board, you see that I make some letters, which means SDG, source, drain and gate. Gate is going on a small circuit, going on the other side, and is going to that small amplifier with those two transistors. Drive is D is the connection for the engine, which is going first into these two wires, which is in fact the terminals from the diode. Oh, sorry. And in the middle, between those two connectors, you find the other connector, which is coming from the MOSFET. Sorry. So you have these two connectors, which is going directly to the engine on this pin, big pin, and in the middle is a wire on the other side of the circuit that is going to D, I think. Yes. And so you have this modification to the board. Going back to the IGBT brick, okay, so we have the gate and we have the source, only for the signal part. Here you see another two crocodile connectors that is going to this oscilloscope, only to see the waveform that is forming from this board. The power connecting, you have the red wire that is going to the minus from the batteries, because this is a N channel connection. Okay, and so you have the plus that is going, the blue wire, directly to the engine, and a black wire that is going on the other side of the IGBT brick. The other two crocodile connections are for this capacitor bank. Okay, so you have few capacitors. I don't know if I can make some focus, but it says 75 microfarads at 200 volts, and we have 5 of them connected to this copper housing or whatever. Okay, let's do a small test to see how it goes. I'm going to focus here on the oscilloscope. Okay, we have this one that is for the throttle, and if we do a little bit of, we can hear that pitch of sound that is coming from the IGBT and condenser, but mainly from the IGBT. And on the oscilloscope we can see the waveform that is producing. I know, maybe he needs some oil on the bearings and something like that, but for now, as a test, we can leave it like this. Let's do this smaller. Let's give an auto set, sorry. And is indicated as a precaution for the IGBT brick to use it on a heat sink, because it's getting quite warm sometimes. Just a few seconds ago it was cold, and now it's pretty warm. It's not extremely warm, but it's enough. So I think I will mount it on a radiator. I have one ready for this specific job. We have here a big one, and so we are going to put this here so that is going to dissipate just a little bit of the heat. Maybe he needs some thermic paste to make a better connection, thermal connection. So this is the setup that I made in modifying this module, electronic module, from a small scooter, a Chinese made scooter, to power this IGBT brick. There is an idea and the possibility, of course, to use the signal that is coming from here. As you've seen there, the signal wasn't quite pulse wide modulation because of these two transistors. So there is an idea to use a driver, IGBT driver, between this one and the IGBT, only to have more clean pulse wide modulation. The signal from that module is coming pulse wide modulation. If we are disconnecting the gate from the IGBT and we are going to look at the waveform on the oscilloscope, you will see that the signal is square, is truly pulse wide modulation. But because of the internal impedance from this and from this, you have some problems. I can tell that these two transistors gets very hot only because of this reason. So this is only for test purpose only. If you want to use it more time in this kind of setup, maybe it's indicated to use some precaution, especially to use a driver between this one and this one. It's a simple driver with a transistor inside and the optical connection between one side and the other side, and so it's not only connecting, isolating this side from this side, but also maintain the square signal as it is from this one to this one, and so you will have more control and more quality, as I can say like this, on the signal that is going to the engine. For now, as a setup, it's okay. But if you want more, you can try experiment with drivers. Good luck, and we see you on the next video, that I will make more interesting things like this one, only for test purpose. Hopefully one day I will make a video that I am going to show a setup as simple as possible for driving an IGBT, and of course to put this engine to earn some money, if I can say like this, to do something, to power an, something, a lawnmower, or I don't know, a go-kart or something like that. But the idea is to experiment, and so I come out with this idea and I made this video, and I hope you like it. Have a nice day and good luck in experimenting.